Okay, our next topic is motion in straight line. That means motion of a body in the straight line. If a body moves in the straight line, then we suppose that the body to be moving in the x-axis. That's why for S, if the particle is moving in the straight line, then we choose the line to be x-axis. That means the body is moving in the x-axis, we suppose. At t is equals to 0, we suppose the particle is at origin. The position of the particle at time t is given by x coordinate at that time. The velocity of the particle is given by v is equals to dx by dt. Here this v is equals to dx by dt gives the magnitude of the velocity. If the sign of dx by dt is positive, then the velocity is along the x-axis, and if the sign of dx by dt is negative, then the velocity of the particle is in the negative x-axis. That's why if velocity is positive, the body is moving along the towards the positive x-axis. If the velocity has negative sign, then the body is moving towards the negative x-axis. And the acceleration is derivative of velocity with respect to time. That's why a is equals to dv by dt. That is, a is equals to d by dt, but v is equals to dx by dt. That's why acceleration is second derivative of displacement with respect to time. Here the magnitude of the velocity v is the speed. We have already studied that magnitude of the velocity v is speed. If the velocity and acceleration are positive, speed increases. That means if both velocity and acceleration are positive, then the speed of the body increases. If both are negative, that means if velocity and acceleration both are negative, then also speed increases. If velocity and acceleration have opposite signs, that means if acceleration and velocity have opposite signs, then the speed of the body decreases. When the speed decreases, then we say the body is decelerating, and deceleration is also known as negative acceleration. That means deceleration, saying deceleration is same or equivalent to say negative acceleration. Example, an acceleration of 4 meter per second square towards east is same to say as deceleration of 4 meter per second square towards west. Now let's move to the next concept. Motion in straight line with constant acceleration, motion of the body in the straight line with constant acceleration. Suppose a body is moving with constant acceleration a. Let the velocity of body at time t is equals to 0. That means initially the velocity be u and velocity at any time t is v. Now, according to the definition of the acceleration, acceleration is equals to derivative of velocity with respect to time. That's why a is equals to dv by dt. Rearranging this equation, we get dv is equals to a dt. Now integrating both sides with limits, with appropriate limits, that means when time is equals to 0, then the velocity is u, and when time is equals to t, then the velocity is v. Integrating in these limits, we get b from u to b is equals to a times time from 0 to t. This gives v minus u is equals to at, and finally we get the equation v is equals to u plus at. This is our first equation of the motion in the straight line with constant acceleration. Also, velocity at any time in this equation, velocity this v, velocity at any time can be given as first derivative of displacement with respect to time. That's why we can write dx is equals velocity is equals to dx by dt is equals to u plus at. Again, taking this dt to the right side, we get dx is equals to u plus at dt. Now, if we suppose initially at time t is equals to 0, the body is at origin, then we can write at time t is equals to 0, the displacement of the body is 0, and at time t is equals to t, at time t, the body is at x, the position of the body is x, the displacement is x, and we have integrated here with proper limits, this will give x is equals to, integrating this will get ut plus half at square. This is our second equation of the motion. And again, from the first equation of the motion, if we square it, then we will get b square is equals to u plus at whole square, b square is equals to u square plus 2u at plus a square t square. And from these two terms, if we take out the common 2a, then inside, after taking out the common, we will get ut plus half at square. This is the, if we substitute its value from the equation 2, then it has the value x, or as x, it has the value x. That's why we can write b square is equals to u square plus 2ax. Here the equation 1, 2 and 3 are the equations of the motion. In these equations of the motions, here x represents the displacement, not the distance of the body. X represents the displacement. The quantities u, b and a may take positive or negative values depending on whether they are directed along positive or negative direction. That means depending on which direction the body is moving in, so the quantities u, b and a may take negative or positive values. Likewise, x may also take positive or negative value. So we have studied about the equations of the motion for the body moving in the straight line with the constant acceleration. And those equations are written here. V is equals to u plus at, x is equals to ut plus half at square, and v square is equals to u square plus 2ax. Here the signs of different quantities, or the quantities v, u, a and x, these quantities may have different signs depending upon which direction, either in the negative or in the positive direction the body is moving. Depending on that, the sign is preferred in these equations. And now one of the simplest example for the body moving in the straight line is the motion of the body, or the motion of the freely falling body. Therefore, freely falling bodies near the earth surface can be considered as the motion of the body in the straight line with the constant acceleration. Here, near the earth surface, the freely falling body have the constant acceleration, that is of 9.8 meter per second square, or 32 feet per second square, near the earth surface, which is directed directly downward toward the center of the earth. And if we suppose the body to be moving in the y-axis, if we suppose the body to be moving in the y-axis, where upward direction is the positive y-axis and downward direction is in the negative y-axis, here if we suppose the acceleration is the direction of the acceleration is towards downward, and that's why here acceleration can be taken as minus g, because the acceleration due to gravity is directed towards the negative y-axis, or negative or directly downward. That's why acceleration is equals to minus g. That's why if we take directly downward as the negative y-axis, then for the freely falling bodies acceleration will be minus g. And if we substitute this acceleration as minus g in this equation, then we will get the equations for the freely falling bodies as v is equals to u, here a is minus g, therefore minus gt, and x is equals to ut minus half a gt square, and v square is equals to u square minus 2ax. These are the equations for the freely falling bodies if we consider directly upward direction as the positive direction and directly downward as the negative direction. That's why acceleration here is minus g. And in some cases, or to make the problems easy, to handle the problems in the easy way, we can consider directly downward direction as the positive y-axis and directly upward direction as the negative y-axis. And in those cases, if we consider directly downward to be the positive y-axis, we can suppose that, then in that case the acceleration will be plus g. And if we suppose directly downward to be the positive y-axis, then acceleration will be minus g. And if we suppose the acceleration to be plus g, then if we suppose acceleration to be plus g, and if we substitute this acceleration value in this equation, then we will get the equations v is equals to u plus gt, x is equals to ut plus half gt square, and v square is equals to u square plus 2gx. Here the downward direction is considered to be the positive direction and upward direction is considered to be the negative direction in these equations. Whereas in this equation, directly downward is considered as the negative direction and directly upward is considered as the positive direction. Now let us take one example. A body is thrown upward with the speed 20 meters per second. Find the maximum height reached by the body. Here we can consider anything, directly upward as a positive and directly downward as the negative, or directly upward as the negative and directly downward as the positive. For instance, for this program, let us suppose directly downward to be the positive direction or the positive y-axis. In this case, here the body is thrown directly upward with the velocity 20 meter, with the speed 20 meters per second. Here speed, initial speed is taken as 20 meters per second. If we suppose downward direction to be the positive and upward direction to the negative, then here the body is thrown upward. That's why the sign here will be minus. Again, find the maximum height reached by the body. At the maximum height, the velocity of the body will be 0. That's why final velocity, this one is initial speed is equals to minus 20 meters per second. Final speed v is equals to 0. Now we have to find the maximum height reached by the body, and now we have the equation v square is equals to u square plus 2g y. Why I have taken the here positive sign? Because the acceleration is directly downward, which is the positive, which has the positive sign. That's why I have taken positive sign here. Now v is equals to 0 is equals to u square minus 20 whole square plus 2 into, I can take approximately 10 meters per second square into y, or it has the value 400 minus 400 is equals to plus 2 into 10 into y, or minus 400 divided by 2 10 the 20 is equals to y. Therefore y is equals to 0 0 cancel 2.3. That means y is equals to minus 20 meter. Here minus 20 shows that, minus sign shows that the displacement is in upward direction, because we have taken upward direction as the minus negative y-axis. That's why the maximum displacement here in the upward direction is 20 meters. Here I have made one slight mistake. In these equations I have written x here, but these are not x, but they are y, because we have considered the equation or the body is moving in the y-axis. Now let's move to the next topic, motion in a plane. How we can deal with the body moving in the plane? If the body has the motion in plane, then we can consider the body to be moving in xy plane. That means the body can be considered to be moving in xy plane. In such case, we can deduce the motion to be the motion in x-axis and y-axis separately by finding the components required, of required quantities, that is of displacement, velocity and acceleration along x-axis and y-axis respectively. This means if the body is moving in the plane, and if we consider the body to be moving in the xy plane, then the problem can be reduced to the two problems. That means the body moving in the x-axis and the body moving in the y-axis. Here, for x-axis we have to find the x components of different quantities like displacement, velocity, and acceleration. And for the motion along the y-axis, we have to find the components of this displacement, velocity, and acceleration along the y-axis. And in those cases, if we reduce the components, then for the motion in x-axis, we can use these equations. That means we can use these equations, and for the motion in the y-axis, we can use these motions of the these equations for the motion of the body. To understand these concepts, let's take one example to be clear in this concept. Here, the example is a particle moves in xy plane with a constant acceleration 4 meter per second square in the direction making an angle 30 degree with x-axis. At t is equals to 0, the body is at origin and its velocity is 8 meter per second towards x-axis. Find the velocity and the position of the particle at 4 seconds. We can draw the figure for this question. Here is xy axis, and initially the body is moving with a constant acceleration, that is 4 meter per second square, making an angle 30 degree with the x-axis. And initially, that means at t is equals to 0 time, the body is at origin, and at this time, that is at t is equals to 0 time, the body has the velocity along the x-axis, and the magnitude of the velocity is 8 meter per second. So this problem can be separated into two problems. That means the motion of the body in x-axis and the motion of the body in y-axis. And for the motion in x-axis, we have to find the components in x-axis. Here, the component of initial velocity in x-axis is 8 meter per second, and acceleration, the component of x component of acceleration is 4 into cos 30 degree is equals to, we'll get 2 root 3 meter per second square. Again, for the motion in y-axis, y component of initial velocity is equals to 0, because there is no velocity initially in the y-axis, in the y direction. That's why uy is equals to 0, and y component of the acceleration is 4 sin 30 degree is equals to 2 meter per second square. Now here we have asked to find the velocity and position. Now let's do for the velocity. Let us take the velocity. The final velocity in the x direction can be found by this equation. Vx is equals to ux plus axt is equals to 8 plus 2 root 3 into 4, or final x component velocity is, final velocity in x direction is 21.8 meter per second. Again, for the final velocity in the y direction, Vy is equals to uy plus ayt is equals to 0 plus 2 into 4. Therefore, Vy is equals to 8 meter per second. Here we have found the velocities of x component and velocities in x direction and y direction separately. Now we can find the velocity. V is equals to root under Vx whole square plus Vy whole square is equals to, finally we will get 23.28 meter per second. That means after 4 seconds, the velocity or the speed of the body will be 23.28 meter per second. And what will be the direction of the velocity? We can find by using this formula. Tan theta is equals to Vy over Vx is equals to 8, because Vy is equals to 8 and Vx is equals to 21.86 meter per second, and thus we get theta is equals to 20 degree. That means the final velocity after 4 seconds is 23.28 meter per second in the direction 20 degree from the x-axis. Again, next we have asked to find the position of the particle at 4 seconds. We can find x coordinate and y coordinate separately, and that's why here for x coordinate, x is equals to uxt plus half axt square. In this way we get x coordinate to be 59.7 meter after 4 seconds. Also y coordinate, for y coordinate we can use this formula, and finally we will get y coordinate to be 16 meter after 4 seconds. Hence the position of the particle at 4 seconds is 59.7 meter in, this is the x coordinate, and 16 meter, this is the y coordinate. One of the example for body moving on a plane with a constant acceleration is the projectile motion. Here, what do we mean by the projectile motion? Near the earth surface, when a body is projected by making a certain angle, then the body follows the parabolic path and falls on the earth surface, and this type of the motion is known as the projectile motion. For a projectile, the acceleration near the earth surface can be considered to be constant, or the acceleration will be the constant, and the acceleration is only g in the downward direction. Here I have drawn one figure in the xy plane of the projectile. Here the projectile is projected from the origin and it follows the parabolic path and falls at the point B. In this projectile motion, the distance or the displacement from O to B is called the horizontal range, and the total time taken by this projectile to reach from this point O to point B is called the total time of the flight. And from the x-axis, the maximum height reached by the projectile, that means the maximum height will be at point A. That's why the maximum height reached by the projectile is known as the maximum height. And since this problem is in xy plane, we can deduce these problems in two separate problems. That means the problem or the motion along x-axis and the motion along y-axis. Now let us take out the components of the different quantities, that means of the velocity and acceleration along x-axis and y-axis. Here, initial x component of the initial velocity is u cos theta, and the acceleration in the x-axis is 0. Again, initial velocity along the y component is u sin theta, and acceleration along y-axis is minus j. Here minus sign is given because the acceleration is in the downward direction, and the downward direction is considered here to be negative y-axis. Now the total time of the flight, now let us take out the total time of the flight. Here we have one equation along the y-axis as y is equals to uyt plus half ayt square. When the body or the projectile reaches the point B, then the y coordinate here is 0. That's why let us substitute here y to be 0 to find out the total time of the flight. In this equation, I have substituted the y component of the initial velocity and the y component of the acceleration. I have got this equation, and now putting y coordinate to be 0, and in the right hand side taking out t to be common, we will get t times u sin theta minus half gt square. This gives t is equals to 0. That means this shows that this equation tells that the y coordinate of the projectiles is 0 at a time t is equals to 0. That means initially the y coordinate is 0 when the body is at O. Again, u sin theta minus half gt is equals to 0. This gives t is equals to 2u sin theta over g. That means next time the y coordinate will be 0 at the time t is equals to 2u sin theta over g. This is for the body at point B. That's why this expression or this equation gives the total time of the flight for the projectile body or the projectile motion. Now horizontal range. For the horizontal range, the body has moved from point O to B. The distance from or the displacement OB is known as the horizontal range. And in the x-axis motion, we have one equation: x is equals to uxt plus half axt square. In the x direction or in the horizontal motion, the acceleration is 0. That's why this term will be 0. and now putting or the substituting the values, x is equals to u cos theta into time. Here I have put the time to be total time of the flight, because from reaching for the projectile to reach from O to B, the total time is taken. That's why total time here is total time of the flight, 2u sin theta over g. This will give here x for the total time of the flight is range, horizontal range. That's why horizontal range is equals to u square sin 2 theta over g. Again, the maximum height reached by the projectile can be found as, one of the equation is by square is equals to ua square plus 2ay y. At the maximum point, the velocity along the y direction will be 0, and that's why putting the velocity along the y direction to be 0, by to be 0, will get u sin theta whole square minus 2g as. Here I have substituted y to be s, because this will be the maximum height reached by the projectile, and simplifying this will get h is equals to u square sin square theta over 2g. This expression gives the maximum height of the projectile. Let us take one example of the projectile motion. A stone is thrown at the speed 20 meter per second, making the angle 45 degree with the earth surface. At what distance the body will hit the earth surface? That means it is asking for the horizontal range. The speed u is equals to 20 meter per second. Angle of the projection theta is equals to 45 degree. Now the horizontal range, formula for horizontal range is u square sin 2 theta over g is equals to 20 square into sin 2 into 45 degree. This will give 90 degree. Sin 90 degree has the value 1. That's why 20 square 400 divided by 10 is equals to 40 meters. That's why horizontal range of the projectile is 40 meters. Let's move to the next topic, and our next topic is change of the reference frame. So far we have talked about the motion of the particle in a single reference frame. In any situation or in any problem, any reference frame can be chosen for according to the convenience of the problem. The position, velocity or the acceleration of the particle totally depends on the chosen reference frame. Now let us see how we can relate the position, velocity and acceleration of a single particle when the particle is observed from two different frames. Now let us consider there are two reference frames, S reference frame and S dash reference frame, and the particle P is observed from both of these reference frame. One reference frame may be moving with respect to the another reference frame. Now for the particle P, if it is observed from the S reference frame, then the position vector for particle P with respect to S reference frame can be given by OP vector, and let this OP vector be denoted as like this. This shows position vector of particle P with respect to S. Likewise, the position vector of particle P with respect to S dash frame, it will be given by O dash P vector. Let it be denoted as R vector P comma S dash. It shows position vector of particle P with respect to S dash frame. Again, the position vector of S dash frame with respect to S frame can be given by O dash vector, and it is denoted as R vector S dash comma S. It shows position vector of S dash frame with respect to S. Now here, if we apply the triangle vector rule, then we'll get OP vector is equals to O dash vector plus O dash P vector. Or if we substitute, then position vector of particle P with respect to S frame is equals to position vector of S dash frame with respect to S frame plus position vector of particle P with respect to S dash frame. In this way, we can relate the position vector of the particle if the particle is observed from two different frames. Again, if we differentiate this equation with respect to time, then we know that if the position vector is differentiated with the time, then it will give the velocity, and finally we will get velocity of particle p with respect to s prime is equal to velocity of s dash prime with respect to s prime plus velocity of particle p with respect to s dash prime. If we can write this equation in this way also, the velocity of particle p with respect to s dash prime is equal to velocity of particle with respect to s prime minus velocity of s dash prime with respect to s prime. This this equation is not correct in the two conditions, and the conditions are if the reference frame or the relative or one reference frame move with respect to another reference frame with very high speed as comparable to the speed of the light, and the next condition is if one reference frame rotate with respect to another reference frame, then also this this equation will not be correct. This equation will be correct only if one reference frame translate with respect to another reference frame with very small velocity. Again, if we differentiate this equation with respect to time, then we know that the differentiation of velocity with respect to time gives the acceleration. That's why finally we will get acceleration of p vector with acceleration of particle p with respect to s prime is equals to acceleration of s dash prime with respect to s plus acceleration of particle p with respect to s dash. Now, if this term is 0, that means if one reference frame is not accelerating with respect to another reference frame, then we will get acceleration in both reference frames are equal. That's why we can say if one reference frame is moving with respect to another reference frame with uniform velocity, then acceleration in acceleration of the particle observed from both reference frame will be equal. Now let us take one example to understand about this concept. So the example is a man is moving on a road with the speed 3 km per hour towards east. Rain fall vertically with a speed 4 km per hour. Find the velocity of rain with respect to man. Here are two reference frames. One is ground and the next is man. Here speed of the man is given 3 km per hour towards east. This is the speed of the man with respect to the ground. Again, speed of the rainfall is given, which is directly downward, and this magnitude of the speed is also given with respect to the ground. That's why we can say speed of the man with respect to ground is equals to 3 km per hour, and the speed of the rain with respect to the ground is equals to 4 km per hour. Now we have to find speed or the velocity of the rain with respect to the man. Now we have the formula of two different reference frame. Velocity of the rain with respect to ground is equals to velocity of man with respect to ground plus velocity of the rain with respect to the man. Or in another way, we can write velocity of the rain with respect to man is equals to velocity of the rain with respect to ground minus velocity of the man with respect to ground. That's why here we have to subtract the velocity of the rain with respect to ground minus velocity of the man with respect to ground. Here is the figure. This shows the velocity of the man with respect to ground, and negative of it is velocity of man with respect to ground in the west direction. This one is the east direction and this one is the west direction, and the velocity of the rain is vertically downward 4 km per hour. Now the velocity of rain with respect to man will be obtained by addition of this vector velocity of rain with respect to ground plus negative of the velocity of man with respect to ground. Now since the angle between the vectors are 90 degrees, that's why we can find the velocity of or the magnitude of the velocity of rain with respect to man is equals to root under 3 square plus 4 square is equals to 5 km per hour. Again, if we have to find the direction of the rain with respect to the man, then let the direction be theta with respect to the vertical direction, and thus we get tan theta is equals to 3 by 4. Therefore theta is equals to tan inverse 3 by 4 with vertical. That's why the velocity of rain with respect to main is 5 km per hour in the direction 10 inverse 3 by 4 with vertical.